Myself, Dr. T. Dhananjay Rao, working as Assistant Professor in the Department of Chemistry. Today, I am going to discuss about derivation of n-nest equation and applications. In this session, I am going to cover what is n-nest equation and its derivation, and n-nest equation and its applications, and some numerical problems on n-nest equation. What is n-nest equation? What is n-nest equation? The n-nest equation provides the relation between the cell potential of an electrochemical cell and the standard cell potential and the temperature and the reaction quotient at non-standard conditions. What is n-nest equation? The n-nest equation provides the relationship between the cell potential of electrochemical series, means E cell, and the standard cell potential, means E0 cell, the potential at standard conditions, and temperature T, and the reaction quotient, means we indicate with Q. This is the concentration of product minus concentration of reactant in a chemical reaction at non-standard conditions. The derivation of n-nest equation. Derivation of n-nest equation. As we know that from thermodynamically, delta G equal to minus NF E cell. What is delta G? Change in Gibbs free energy. Delta G nothing but change in Gibbs free energy. What is N? N is number of electrons involved in electrochemical cell. What is F? F nothing but Faraday constant. That value is 96,500. E cell means cell potential, cell electrode potential. At standard conditions, what? The electrode concentration 1 molar and the temperature 298 Kelvin. If I take these standard conditions, then delta G becomes delta G naught. What is delta G naught? Change in Gibbs free energy or standard Gibbs, change in standard Gibbs free energy in case with delta G naught. N nothing but number of electrons. F is Faraday constant. What is inner cell? The cell potential at standard conditions or standard electrode potential. Inner cell nothing but standard electrode potential. According to thermodynamics, we know that delta G equal to delta G naught plus 2.303 RT log Q. What is delta G naught? Change in standard Gibbs free energy. Delta G equal to change in Gibbs free energy. R is universal. Delta G change in Gibbs free energy. Delta G naught change in Gibbs free energy at standard conditions or standard Gibbs free energy. R is universal gas constant. The value of R is 8.314 joule Kelvin inverse and mole inverse. T equal to absolute temperature 298 Kelvin. What is Q? Is reaction quotient. Q nothing but the concentration of product divided by concentration of reactant. Put the values of delta G and delta G naught. Already we know delta G equal to minus NF E cell and delta G naught equal to minus NF E naught cell. Put these values in the above equation. In this equation, see what happens, we'll see. Delta G in place of it will come n minus NF E naught cell. Delta G naught equal to minus NF E naught cell plus 2.303 RT log Q. The equation becomes minus NF E cell equal to minus NF E naught cell plus 2.303 RT log Q. Divide above equation both sides with minus NF. What happens, we'll see. The equation is minus NF E cell equal to minus NF E naught cell plus 2.303 RT log Q. Divide both sides with minus NF. What happens, we'll see. Minus NF and minus NF. Minus NF get cancelled. Here also minus NF get cancelled. Here minus and plus. Here it will comes minus. So next will become E cell equal to E naught cell minus 2.303 RT by NF log Q. Okay. Now we substitute the values of R, T and F. Already we know R value is 8.314. Okay. T is 298 kelvins and F is 96,500. We substitute these values in this equation. What equation becomes? Substitute the values in this E cell equal to inert cell minus 2.303 R 8.314, T value 298 and N we don't know N, so I am keeping like N only. Then F is 96,500 and log Q. This the total value becomes 0.0591. So what happens? This equation becomes E cell equal to inert cell minus 0.0591 by N log Q. This total value becomes 0.0591. First, suppose if a reaction undergo oxidation. What is the nearest equation for oxidation reaction? We will see. The metal undergo oxidation, it forms N electrons. The nearest equation can be written as E cell or oxidation potential of E cell equal to E naught cell minus 0.0591 N and log Q. Log Q nothing but concentration of product divided by concentration of reactant. Okay. Here see the concentration of product is concentration of M Q equal to concentration of M plus N divided by concentration of M. Okay. The solid phase concentration always be taken as unity. For solid phase the concentration taken as unity. So for concentration of M I am taking as 1. So Q becomes M plus N. So if I take M equal to 1, the final equation becomes for oxidation. This is the nearest equation for oxidation potential. E cell equal to E naught cell minus 0.0591 divided by N log of M plus N. Similarly, for reduction reaction, M plus N takes N electrons and forms metal. The nearest equation can be written as E cell or reduction potential equal to E naught cell minus 0.0591 N by log Q. Log Q. Q nothing but concentration of product by concentration of reactant. What is the concentration of product? Concentration of M divided by concentration of M plus N. Already I have said for solid I am taking the concentration of metal solid is unity. So I am taking instead of M is 1 by M plus N. So the final equation becomes E cell equal to E naught cell minus 0.0591 divided by N log 1 by M plus N. This is the nearest equation for reduction cell reaction. Write the nearest equation for following reaction. Zinc reacts with copper, forms zinc plus 2 and copper. First, we have to know how many electrons involved in this reaction. We have to find out first. In this first see, which one undergo oxidation? Zinc undergo oxidation. The oxidation reaction is zinc undergo zinc plus 2 and 2 electrons. Which one undergo reduction here? Copper takes electrons and forms copper. So copper undergo reduction. Copper plus 2 takes 2 electrons and forms copper. What is the total reaction? Zinc reacts with copper plus 2 and forms zinc plus 2 and copper. See, in this reaction how many electrons are involved? 2 electrons are involved in reaction. So next equation can be written as E cell E naught cell minus 0.059 by 2. Now I am taking N as 2 since 2 electrons are involved in the reaction. So log of Q. Q nothing but concentration of product divided by concentration of reactant. See, the concentration of product Q equal to concentration of product means zinc plus 2 concentration into copper concentration divided by concentration of zinc and concentration of copper plus 2. Copper and zinc are metals, so I am taking this concentration as 1. So Q becomes zinc plus 2 and copper plus 2. So instead of Q, I am writing the zinc plus 2 and copper plus 2. So this is the final equation for this nearest equation of zinc and copper reaction. Applications of nearest equation. The potential of an electrode and EMF of a cell can be calculated at any temperature and concentration. The EMF of a cell or potential can be calculated at any temperature and at any concentration of electrolyte solution. Knowing potential of an electrode, the concentration of the reactant can be calculated. By knowing the potential of electrode, we can calculate the concentration of that electrolyte or reactant. Determination of equilibrium constant. By using nearest equation, we can calculate the equilibrium constant also. The pH of solution can be calculated by measuring the EMF. By measuring the EMF using nearest equation, we can calculate the pH of that solution also. The solubility product of sparingly soluble salts can be measured. The solubility product of sparingly soluble salts can be measured by using this nearest equation. Question. First question. Calculate reduction potential for the following half-cell reaction at 298 Kelvin. Given silver concentration 0.1 moles and standard reaction potential is plus 0.80 volts. This is the reaction he has given. Okay. First, according to nearest equation. According to nearest equation, E cell equal to E naught cell minus 0.0591 divided by N, and log the concentration of product minus divided by concentration of reactants. Q equal to Ag concentration divided by Ag plus concentration. But Ag is solid, so we have taken it as 1 by Ag plus. So substitute this in this. Okay, this is the equation for the nearest equation for this reaction. Okay, in this reaction, how many electrons are involved? In this, only one electron is involved to complete the reaction. So N equal to 1. So E cell equal to E naught cell he has given 0.80. So E naught cell I have written 0.80 and minus 0.0591, N equal to 1 and log 1 by Ag plus 2 concentration he mentioned 0.1. Okay, then equation is E cell equal to 0.80 minus 0.0591 by 1 log of 1 by 0.1. 0.1 we can write as 10 to the power of minus 1. So E cell equal to 0.80 minus 0.0591 divided by log of 1 by 10 to the power of minus 1. If this 10 to the power of minus 1 goes to the numerator, then minus 1 become plus 1. So E cell equal to 0.80 minus 0.0591 divided by log of 10 to the power of 1. Already we know log 10 equal to 1. So E cell becomes 0.80 minus 0.0591. Finally, E cell potential we will get 0.741 volts. Example 2. What is the cell potential of the electrochemical cell in which the cell reaction? He has given cell reaction and given that E naught cell of the reaction and temperature he mentioned 25 degrees centigrade. 25 degrees centigrade nothing but we have to convert into Kelvin. So for that we have to add 273. So we will get 298 kelvins. 25 degrees nothing but 298 kelvins. Here the cadmium concentration he mentioned and lead concentration he mentioned. Then nearest equation is E cell equal to E naught cell minus 0.0591 divided by N log Q. First we have to know the how many electrons involved in this reaction we have to find out. See, in this Pb plus 2 converting to Pb and means Pb undergo reduction. Cadmium forms cadmium plus 2. So cadmium undergo oxidation. So first we have to write oxidation reaction and reduction reaction. By using this reaction we have to write cadmium undergo oxidation forms cadmium plus 2 and 2 electrons. At the same time Pb plus 2 takes 2 electrons undergo reduction forms Pb. The complete cell reaction is cadmium plus Pb plus 2 gives less cadmium plus 2 and Pb. This is the final reaction. So Q becomes the concentration of product divided by concentration of reactant. So cadmium plus 2 concentration of Pb by concentration of cadmium into concentration of Pb plus 2. We know Pb and cadmium are solid. So I am taking this concentration as 1. So Q becomes cadmium plus 2 and Pb plus 2. So the key value substitute this. Then the equation becomes E cell. E cell equal to E naught cell he has given 0.277 volts. Substitute this one and 0.051 divided by N. N means number of electrons involved in this reaction. So 2 electrons are involved in this reaction. So N equal to 2. Log of cadmium plus 2 divided by concentration of Pb plus 2. E cell equal to 0.277 minus 0.051 log the concentration of cadmium plus 2 is 0.02 molar and the concentration of Pb plus 2 is 0.2. Then this value 0.02 divided by 0.2 becomes log of 0.1. Then this equation becomes E cell equal to 0.2771 0.0591 divided by 2 log 0.1. Log 0.1 we can write as 1 by 10 log 10 to the power of minus 1. Okay, log 0.1 we can write minus 1. So E cell equal to 0.059 divided to nothing but 0.0296 and log 0.1 value is minus 1. So E cell equal to 0.277 minus 0.0296 into minus 1. Log 10 to the power nothing but minus 1. So log 0.1 is minus 1. So E cell equal to minus into minus becomes plus. E cell equal to 0.277 plus 0.0296 equal to 0.3066 volts. The net cell potential here EMF is 0.3066 for this reaction. The third problem. The standard reaction potential of zinc plus 2 zinc and copper plus 2 copper are given. What is the EMF of the cell? He has given cell representation model he has given. First find out which one is anode and which one is cathode. He has not given E naught cell. First we have to find E naught cell. Standard reaction potential you have to find out. Then we have to find the E cell. E naught cell. First we have to in this cell representation the left side one is anode. So E anode is zinc to zinc plus 2 equal to and how much is given? Minus 0.76 volts he has given. E cathode, the right one is cathode, means Cu plus 2 Cu is given 0.34 volts. What is E naught of cell? E naught of cell is nothing but E naught cathode minus E naught anode. Which one is cathode? The copper is cathode in this cell. So 0.34 volts minus 0.076 volts. Then minus into minus become plus 0.34 plus 0.76. The E naught cell becomes 1.1 volts. Then we have to calculate by using the next equation in E cell. So E cell equal to E cell equal to E naught cell minus 0.0591 divided by N log of this concentration. How we will get this? We will see. At anode reaction takes place. Which one is anode? Zinc is anode. So zinc undergo oxidation. It forms zinc plus 2 and 2 electrons. Here copper is cathode. Undergoes reduction. Copper plus 2 and 2 electrons. It forms copper. So complete reaction is zinc and copper plus 2 gives zinc plus 2 and copper. How many electrons involved in this reaction? 2 electrons are involved in this reaction. So N value equal to 2. So Q equal to concentration of product means zinc plus 2 concentration and concentration of copper divided by concentration of reactant means concentration of zinc and concentration of copper plus 2. copper and zinc are metals. So instead of copper and zinc, we substitute 1. So Q becomes concentration of zinc plus 2 divided by concentration of copper plus 2. Substitute this values in the Q. So the equation becomes E cell equal to E naught cell minus 0.0591, N equal to 2 and log of zinc plus 2 by copper plus 2 concentration. Already E naught cell we have calculated, we got 1.1 volts. Substitute this value here and 0.0591 divided by 2 log zinc plus 2 concentration he has given 0.05 molar. Okay, and copper plus 2 concentration is given 0.005 molar. So this value becomes 10. This 0.05 divided by 0.005, this is value is 10. So this equation becomes E cell equal to 1.1 minus 0.0591 divided by 2 log 10. Log 10 nothing but 1. So E cell equal to 1.1 minus 0.0591 divided by 2. The final answer is E cell is 1.07 volts. Problem number 4. Write the overall cell reaction. This is the electrochemical cell representation as given, and calculate the EMF of the cell at 25 degrees centigrade. 25 degrees centigrade nothing but 298 Kelvin. And standard EMF of the cell 1.4. E naught cell as given 1.5 volts. First we have to know the how many electrons involved in the reaction. I have to find out first. Then complete cell reaction we have to know to get the Q value. So if this is cell representation, left side is anode and right side one is cathode. So at anode oxidation takes place. So zinc undergo oxidation, forms zinc plus 2 and 2 electrons. At cathode reduction takes place. So silver undergo reduction. Ag plus 2 takes 2 electrons and form silver. The complete reaction is zinc and plus Ag plus 2 gives less zinc plus 2 and Ag. The Q is nothing but concentration of product terms and concentration of reactant terms. So concentration of product means concentration of zinc plus 2 and concentration of Ag, and concentration of zinc and concentration of Ag plus 2. Silver and zinc are electrodes. So this concentration becomes 1. So Q becomes zinc plus 2 by Ag plus 2. Okay. Instead of Q, you have to written zinc plus 2 divided by Ag plus 2. How many electrons involved in this reaction? 2 electrons involved in the reaction. So N equal to 2 we have to take. So E cell equal to E naught cell minus 0.059, N equal to 2, and instead of Q you have to write zinc plus 2 divided by Ag plus 2. E cell equal to the standard reaction potential. E naught cell is mentioned. The standard reaction potential value is minus 0.76 we mentioned. Sorry, the standard EMF is minus 0.76 volts. The E naught cell is given minus 0.76 volts minus 0.0591 divided by N is nothing but number of electrons are 2. Log of zinc plus 2 concentration. What is the zinc plus 2 concentration? 0.2 molar, and Ag plus 2 concentration 0.002 molar. If you calculate this one, you will get 10 square. Then E cell equal to minus 0.76 minus 0.0591 divided to log 10 square. Log 10 square nothing but we can write as log of m power n equal to n into log m. So 2 into log 10 it will become. Log 10 square become 2 into log 10. Log 10 nothing but 1. 2 into 1. So this value becomes 2. So the equation becomes minus 0.76 0.0591 by 2 into log 10 square value into 2. 2 get cancelled. Then E cell equal to minus 0.76 minus 0.0591. The final solution is E cell equal to minus 0.8191 volts.
Like, share and subscribe. Hit the bell icon for more updates.
Thank you.